I'm not going to talk about Splunk. I'm going to use a lot of screenshots from Splunk because they're the ones I have access to, right? I'm going to talk about data. I'm going to talk about using data. I'm going to talk about advanced ways to use data. Again, I'm a public company. Anything I say today that it talks about futures, please go and look at our currently available offerings on our website. With that done. So this is what I'm going to talk about. A little bit about data, machine learning, and this new concept of AI for ITOps. I'll define it and tell you what that means. Talking about how do you run that through a data processing service so you can get the good outcome. So you've got to collect the right data, train your machine learning systems, and then operationalize it so you get the good results. And I'll talk a little bit quickly about why visualization is important when you start talking about data. So, let me start with just using data for better decisions, right? So when I think about NewOps and I think about new ways of operations, I think about, well, where have we come from and what do we need to do differently? So I certainly think about the idea of taking just structured data, rows and columns, databases, right? We've been using them for years and years and years. Now we've got almost infinite amount of data, unstructured data, semantic data. You think about tweet streams, for example. I mean, that's a hard piece of data to start to corral. I think about the old brittle tools, the integration, point-to-point integrations, and now we're much more about open and well-defined APIs and robust integrations through data. It's interesting that when Michael was on stage, he talked about SNMP and how we've been living with SNMP, and frankly, we're better than that, and I couldn't agree more. Getting real-time insights from data rather than just waiting for traps to come, waiting for alerts to come. Focusing on components. We used to focus on servers and network devices, switches, this storage array over here. Now it's much more about the service that we're delivering. I was talking to an SRE at one of the big video streaming companies recently, and the metrics that person monitors is not uptime, not availability, it's not response, it's not server load. It's a successful video starts. So there's an engineer, there's an IT operations person, now an SRE, and their core metric is how many people are watching videos and how easy was it for them to watch a video. So it's about the service they're delivering, not the individual component parts that deliver that service. And we used to search, we used to grep logs, we used to search through alert streams. There's too much data. The presentation I showed at the introduction talked a little bit about where all of this data is coming from. And so this is where I firmly believe you've got to apply the machines to figure out what all this data is telling you. So this is what's driving this concept of AI ops. So it started out being called algorithmic IT operations, and then the people who created it looked at it and realized that everyone was calling it AI for ops, artificial intelligence for IT ops. So they changed that name. And it's software. It combines data and machine learning to improve the processes around IT operations, especially around monitoring, service desk, and automation. It's a Gartner thing, but I think it makes a lot of sense to me in my world. So when you look at how do you apply ML and AI to IT operations data, well, you get the data in, right? You acquire the data, so you can start figuring out, well, what does it start to mean? You then need to train your algorithms. So machine learning, it needs to learn what's right and what's wrong. And so you tell it what is and what isn't, and then it starts to learn. So you train your algorithms, you find the right algorithm. Then you apply it to your data, and you apply it to known data so you can validate, this is my normal load cycle, that's normal, that's good. What does it look like if I apply machine learning to it, and what do I learn from it? And then you can reuse that model and start to operationalize it throughout the process. So step one is acquiring the right data. Lots and lots of ways to acquire data. I don't think we've got a shortage of data, but typically, as you were talking with Michael and others, measuring events and metrics is how the site reliability engineers tend to operate in these large cloud scale environments. So instead of monitoring consoles, you just look for the numbers, and when the numbers show exceptions, you start to react to it. So a metric is really just a number. It's a little bit more than that. Typically, a metric will have a timestamp. It'll have, obviously some kind of value. Often it'll have a name, and it often has other kinds of dimensions, like what box is it running on, what Amazon region is it running in, just sort of a little bit of metadata about the metric. So now you can start to think of these metrics as CPU time or availability, response time, latency, number of successful video starts, and a whole bunch of other things. Then you get events. So Michael mentioned this. He monitors metrics and events and traces. So an event typically is instantiated as some kind of log statement. It could be a console message. It could be an alert coming out of a third-party system. The interesting thing, this is a sort of complex log message. Not that complex because it's sort of readable in English language. But the interesting thing is you can also turn events into metrics. So now you can start to monitor based on these individual numbers, these metrics, and you can start making decisions based on this data. So this gives rise to, and both Michael and the gents from Disney were talking about observability. This is a new-ish concept in IT. It comes from manufacturing and other industrial systems. It's a part of control theory. How do I control the manufacturing process? And to control the manufacturing process, you need to know what's happening inside that manufacturing process. So it's just observability is not something you buy. It's not a capability of a monitoring tool. Observability is a function of the system you're monitoring. And it's that system exposes its internal workings to you externally. So coming from a manufacturing or an industrial background, the example I like to use is a water treatment plant, right? So you've got a pipe. Can't see inside the pipe, no idea what's happening inside the pipe. There's water going in, it's dirty, there's water coming out and it's probably clean, but I still don't know what's happening inside the pipe. So I install some sensors inside the pipe. And so I put a flow meter, I put a valve to measure pressures and stuff. I put a purity sensor in there. So now I'm starting to see, I get telemetry. In this case, it's physical telemetry, and I get gauges outside the pipe. So now I know how fast the water is flowing, which way it's going, how clean it is. I've given my system observability. I can observe what is happening inside the system. So we can do exactly the same thing with software. We still have a pipe, but instead of water in, water out, we've got data in, data out. So we've got inputs and outputs. You all know this. And then we have functions that happen inside. So I can put measurement into those functions. So it could be an add to cart and a checkout and a billing function. I can add measurement inside those functions. I can add telemetry. In this case, it's logging or event or metrics emission. And so now I get actual gauges that tell me things about what's happening inside my system. I can see things like customer IDs, whether transactions were successful or not, how much money is being spent by my customers, as well as these infrastructure kind of ideas like CPU and response time and throughput, latency, transaction, round trip times and stuff like that. That's all observability is. And observability data comes from all sorts of places. Right now we're talking a lot about things like getting observability data directly out of the inside of an application. But if you want to know what's happening in your system, then there's all sorts of data that's showing you what's happening inside that system. From your cloud services, from networks, from applications. Oh, and by the way, if I look at this, I can pinpoint what is cloud and what you don't have to do to a large degree. The platform, cloud platform services. A lot of networking is taken care of by the cloud provider. So as you move to an AWS or Azure or Google, for example, you start to not have to worry about that. But you definitely still have to worry about things like what's happening in your mobile environment, your social applications, the monitoring tools, actual customer activity. How about when you're using partners and third-party ecosystem components? So this is telling you what's going on inside that system. And for an example, even in a cloud system, you're getting a lot of observable information about what's going on from multiple different systems and multiple different parts of that Amazon environment. And so that, to start with, helps you with troubleshooting, right? I'm betting a lot of you can look at this and immediately understand where the problems are. You might not be able to read the individual line items, but we've all seen traffic light displays. So now with metrics, I can see, this is normal, and I know that because it's green. So this is all normal, but then we start to see this drop down here, and now I know that it's abnormal. This is the idea of monitoring based on metrics and monitoring based on data. And I can now use that data in a historical sense to be able to go and troubleshoot and triage. I can figure out that, well, this says storage free space on this particular database went to 0. I feel like that's probably the initial problem that triggered this and this and this and this. So now I'm using data to make troubleshooting decisions. But you can also use it for real time, right? So I can now use, this is the idea of using metrics to understand what is the health of my system and be able to sit there and go, okay, it's all fine except, well, now it's all red. In fact, this website has real problems, doesn't it? Only one thing is healthy, and that's the external APIs. So as a real-time monitoring based on data. So you don't have to watch screens and watch line items and tick things off. You see that, and you can see instantly that where things are going right, where things are going wrong. Now, just some examples of that. So monitoring your infrastructure health. So using the metrics that matter in your environment. And by the way, I don't know what metrics matter to you. That's for you to figure out in your environment. It could be video starts, it could be successful logons, it could be server time, response times. But this is infrastructure health. So I can see use space, my hard drive temperatures, so I can start to react. I can start to react based on data rather than, oh, well, it's Tuesday, so I think I have to install a new hard drive because I might be running out of space. Similarly with cloud resources, this is actually really important because in the cloud you don't get to see a lot, but AWS especially, but also Azure and Google and others, they emit an incredible amount of data so you can understand what are you using, what resources are available, what are you spending too much on, so you can start to claw back unused instances and unused storage and start to reduce your costs there. You think of things like in the modern environment, containers. So there's multiple places where you can start to get data out of containers to understand what's going on. At the very lowest level, or the very internal level, is actually the application itself, which can tell you stuff, and I'll show you exactly how in a moment. Then you've got the operating environment within the container. So that starts to spit out stuff like syslog. Then you've got the container itself, so a Docker or whatever it is. And then you've got the control or orchestration systems, like a Kubernetes or a Swarm. All of this rolls up to show you the data that matters about that particular service. And even from things like response time to even potentially things like costing information. So again, as an engineer, you can start to look at this and go, well, what can I do with this data to make my environment better? And also I can troubleshoot with it and I can do real-time monitoring. Same with storage and capacity. I chose this slide because it's virtual storage, so it doesn't really matter. Everything emits this data that you can start to see what's happening inside your systems, including those third-party systems. So increasingly, we're looking at third-party systems via well-defined APIs to be able to do things for us. Shipping is a great one, right? If I'm making T-shirts, I'm not in the shipping business, I'm in the T-shirt business, so I outsource that to a third party. Now, we already do that with all sorts of things, credit card authorizations, probably logistics and shipping, bunch of stuff. Increasingly, that becomes more and more that we're using these third-party services. They give you data as well. In fact, to a large degree, that's all they give you, because it's really hard to install a monitoring agent into a serverless API, right? Can't do it. But what you can do is get the data out of that API that tells you what it's doing and when. So, how do you get this data? So it's coming from all sorts of places, from syslogs, from applications, from containers, from monitoring tools. One good way is CollectD. It's an open source daemon that collects metrics. So it collects a wide range of data, including the metrics that I was talking about. Highly extensible. There's like 120 different plugins for it. As I said, it's open source, mostly used for infrastructure variables. Things like CPU and response time and hard disk temperatures and these sorts of things. But you can get it for things like Apache, for MySQL, and so on. This doesn't generate data. It doesn't analyze data, but it does collect it and transmit it to some other place where you can do that. Another way is with StatsD. Same sort of idea, but for statistics as opposed to for metrics. So things like averages and means and so forth rather than individual numbers. Again, open source, created by Etsy in the first instance, so you can go and check that out. Then you have just the ability to listen in. So you can listen in on things like HTTP events. So on page load, on page open, on mouse over, on mouse click. So now you're starting to get actual payload information. You're starting to see what actual applications are doing. Even without rewriting the application, you can start to see this as long as it's a web application. So you can start to see even things like which customers are buying which products more often. And so now you're starting to, as an IT operations pro, you're starting to have real business relevance. And that's a thing that data can give you. And I think it was Jason was talking about that, the ability to connect what you're seeing in IT with what your business is trying to achieve. And similarly, things like network data. Network data, you can actually look at the payloads, and then you can get all sorts of information around not just the technology, the round trip times and the throughputs and the latencies, but actually the business data. So you start to see things like customer ID, the shopping cart ID. So now we can start to report as operations engineers on things like cart abandonment, cart fulfillment, customer sign-ups, customers cancelling. For banking environments, things like loan originations commenced versus loan originations completed. So we now have an idea of business data that we can provide. So that in turn makes us more essential to our business. And finally, you can create new data. This is the idea of semantic logging. All it means is logs that have meaning. A lot of the time, development will put logs into their code until it goes into production, and then they'll take them all out because it uses memory and space and all that sort of stuff. Get them to leave it in, and you can start to log things with a common logging function that tells you, again, all sorts of internal information about the environment. And this becomes very, very powerful when you start to do monitoring and reporting, not just to your IT teams, but also to your business teams. Oh, by the way, as a side, it's amazing how good your logs become when developers are on call and need them to do their own job. So give your developers pages and you will get nicely formed semantic logs. So we have the data. Now, let's start to use the machines to make more sense of that data. And this comes back to the idea of what certainly Michael and Jason and Brian were saying, the idea of reducing toil and doing more things automatically. So I can start to train my data. So this is a load peak, a load cycle, on any given day, up, down, up, down. The old static flat threshold doesn't even exist anymore. That's not even a thing. Adaptive thresholds that understand your business. So machines can see this sort of stuff. Humans are really bad at this, by the way. We are really bad at seeing long-term patterns. We're really good at seeing very short-term patterns, assuming that they are long-term patterns. So machines have no agenda, they have no history, they just learn what you show. So they can see these patterns. So now you can start to apply multiple different algorithms and see what they tell you. So you can start to take data that's all over the map and start to cluster it together. So you can start to see what are the different clusters. It might be geographic, it might be demographic. It might be to do with a specific set of servers. I mean, you think about hot aisle, cold aisle, and this is a perfect use case for IT monitoring to be able to look automatically and see what are the impacts of having different hot aisle, cold aisle kind of situations in your data center. You can start to forecast time series data even though it's lumpy. You can look at anomalies. And this is really important from a monitoring perspective. You're getting all this data that's showing you, say this is response times. And so you're getting all this data. Mostly this is normal. As my workday goes on over time, or maybe I get more load, maybe I'm running advertisements on television, I get more hits and hits. But then some things start to fall out. So I can see there are anomalies. As an IT operations person, I don't want or need to look at all of this normal stuff. What I need to look at is the abnormal stuff. So the machine can now start to interpret and tell me what's normal and what's abnormal. I can detect outliers, same sort of idea. As a sysadmin and as an SRE, I can look at what's abnormal and address that, rather than trying to always stay ahead of what's normal. So then you take that data and you operationalize it. You make it repeatable and normalized and use it. So this is where you start to manage events. This is an example. You can use machine learning and the data to manage events more intelligently. So collecting all the data, and then you start to de-spam it. You use machine learning to figure out, well, what's actually important and meaningful and what's not. And then you can start to collect it into buckets and start to look at, well, this is, if I've got a lot of, so you start here, right? I've got a lot of alerts, say. I don't know what all these alerts are. I've got 4 different types of alerts and I don't really know what they are. So here I start to go, okay, I know what the 4 different buckets are. So now, what's most important to me? So single sign-on, sales, claims. If I'm an insurance company, I feel like claims is probably one of my most important things, and I would fix that. Sales is probably really important. I'd probably fix single sign-on last, because that's probably an internal system. You know, when you're looking at monitoring and managing your system, say in the cloud, you need to understand the priorities of your systems, but that means you need to understand all of the signals and all of the noise that's coming in, what applies to which system. So if a region goes down, you restart your order entry or your customer sign-up system before you restart your human resources and vacation booking system, for example. So this is a different way of looking at using data, especially in these high volume environments, to figure out what's going on and using the machine to figure out what's going on. So this is where we start to bring machine learning and this idea of artificial intelligence for IT operations to the real world in things like analyzing events. So hands up who's sat in front of a network console and just watched alerts stream past. Okay, keep your hand up if you're sick of putting your hand up. Yeah, good one. I won't ask you that again. I can't guarantee for other presenters. But what we see here is a whole load of events, but they're categorized and collapse. Typically, we get alert storms. When one thing goes wrong, we get 1,000 alerts. And they're all, you know, more or less related to 1 or 2 or 3 proximate causes. There may not be a single root cause, but there's certainly not 1,000 things going wrong. And you think of a network switch failure. That cascades to the middleware, to the application, to the server, to the customer experience. But the problem was the network switch failed. So being able to use machine learning to sift through these vast amounts of alerts and events to try and figure out where is the commonality between these many, many different alerts and events, and what is the proximate root cause of the problem that I'm trying to solve. So you can use the machine learning then to detect and filter and then isolate just those notable events. This is the one thing out of all these 1,000 that you need to pay attention to, because you're using the machine to process all that monitoring data, and this is letting you handle things at scale and at speed. So you can isolate the origin of the disruption and ultimately facilitate that really fast incident review and investigation. Oh, by the way, a couple of people now have spoken about the blameless post-mortem or the post-incident review. So when you're getting all this data in and you're finding all these events and you're pinpointing the notable event, this is all being tracked and traced and audited. So when you go to your post-incident review, you can look through what you thought you saw, isolate what was really important, and use that for 2 things. One is to train your humans to recognize the situations and do the right thing next time. But the other is to train your system. So you use the post-incident review data to train your machine learning algorithms so that next time they recognize the problem faster. That then lets you get into prediction. And that's where things totally change. I'm not going to spend a lot of time on this. This is a whole new session if I wanted to talk about using data for predicting and preventing problems. But once you can see, you get the metrics and data out of all of your system, and not just servers and not just infrastructure, not just applications, but also the business data about customers, about throughput transactions, products, revenue, stuff like that. Once you see that whole system, you can start to apply machine learning and AI to the data and understand the patterns, and now you can start to predict and even prevent problems before they happen. So, I'm just about done, but I did want to point out the importance of visualization. So, good data is really important, but good data is not enough. Like I said, humans are really bad at numbers. Numbers are an artificial construct, by the way. I watched a really interesting documentary a little while ago, I think it was Michael Palin, talking about the invention of zero. So for millennia, zero was not even a thing. No one needed to know what zero was. I wasn't counting my sheep. I either had sheep or I didn't have sheep. I didn't need to have a zero for the sheep that I don't have. Numbers are an artificial construct. And so we're really bad at numbers as human beings. What we're really good at is visuals and stories, just by the way. And so, on this one, it's really hard to see where the value is. This is just data, really hard to see. But in this one, this is exactly the same data. And now I can see, well, I'm in IT, I'm an IT operations person, I see everything's green, right? So I'm happy because I know what that means. It's visual and it tells me a story. Then you got this, right? Same set of data, but this one's showing you a fault. There's an error in here. And it's sort of hard to tell. I mean, I can pick it because I know what I'm looking for. But then you do this, and now it's really obvious. This is, again, it's telling a story, but it's also showing you the outcome. So, can you pick the outages in this? You know, where's what's good and what's bad in these numbers? It's pretty straightforward because it's visual. How about now? Tick boxes, crosses, again, color-coded. It's visual. So good visualizations are important. I can see at a glance exactly which regions I'm having issues with. If I put longitude and latitude with a health score number, I would have no idea what that even meant. So visualization is really, really important. So, just to summarize, I'm a huge fan of using data for IT. And we have so much data, but we make really bad use of it. So being able to use that data at scale, at pace, by driving it into machine learning engines, using AI for ITOps to make our life easier, to free up time so we can focus on things like engineering and improving our reliability, contributing new ideas to the business, doing things which people are really good at, innovation, creation, imagination, and getting the machines to do things that they're really good at, number crunching and analytics. Operationalize those and never, ever forget the importance of visualization. So, bottom line, it's about connecting the data dots. Going all the way from that early incident detection, all the way through to the idea of service restoration, root cause or proximate cause analysis, ultimately getting that business-driven IT because you're starting to monitor, report, and manage on what makes your business better rather than just what makes your servers better. So that's all I've got to say. There's lots of stuff here at NewOps Days. Please visit the Splunk table back there when you have a chance. Go and ask Kirk for a demo if you want to see some of this predictive analytics and so forth in action. Splunk.com, get the machine learning toolkit. You can get free versions to play around with. Learn what machine learning is. There's sample data sets you can play with there as well. So I hope you enjoy that. But now you're in for a treat because I'm done. Have we got time for Q&A? Is that a thing? I feel weird because I'm the host. No Q&A. They're all going, no, we don't want to hear any more from you, which is totally fair. So now we're having one of our first lightning talks. We'll have more after the break, but right now, I think we need a different set of slides up. Melanie from VictorOps, a part of Splunk, is going, what is your talk about?
I am talking about post-incident reviews and mean time to resolution.
So the post-incident review and mean time to resolution. Welcome, Melanie, on the stage. Yes.
All right, thank you. So, thanks, Andy. Yeah, so I know that you've heard a bit about post-incident reviews thus far. So at this moment, before we get into MTTR, I'm going to talk a little bit about a scenario that none of you, I'm sure, have ever dealt with, which is a more reactive response to an incident. So let's start with a story. So Sam is a system engineer. It's 4:03 on a Thursday, and he's going through his ticket queue, kind of doing his normal day's work, and he takes a break. He goes to Twitter, and he notices one customer mentions the company, saying that they can't log into the website. But he's like, I was just in the incident queue. I don't see anything wrong at all. So he goes back to work. But he has this nagging idea in the back of his head. He really just hopes that he's not missing anything. So he logs back into Twitter, and it's definitely a problem. There's a Twitter storm happening. There are people all over the place saying that they cannot log into the website. So he takes immediate action. He creates his own ticket, which is sent to customer success. And the new girl, Carol, jumps in. So she's ready to go, super excited, but doesn't really have all the knowledge she needs to solve the problem that's at hand. So she dives right into documentation. She goes into Confluence, for instance, and finds a way to log into the website and look at the logs to understand what's going on. So she does this. She thinks that she has a pretty good grasp of what she needs to do, but she's new, and she wants a second pair of eyes just to be sure she's doing the right thing. So she asks around, And Greg happens to be the expert in this domain of their system, so she slacks him, which is the normal first mode of communication. Doesn't hear anything back for a few minutes and tries to email him. Doesn't hear back again. So now she's like, well, I don't know how to get in touch with Greg. So she goes through her email and eventually finds a mobile phone. And unfortunately, Greg is out of pocket because he's at his daughter's second birthday party. This is pretty common, you know, he's having a great time, not really thinking about work all that much, but he does respond to that phone call, and he is super happy to jump in. So he joins the party, he corroborates, he says, yes, Carol, exactly what you thought was wrong is the problem, so he just redistributed some load balancers and went on his merry way. He tells Carol to update Sam, and everything's perfect. Everything's great again. And that's it. So that was a lot, but in the scheme of things, that was a relatively straightforward incident and response. So at the same time, how much do you think of this was actually documented? Probably not very much. So from the outside, or even from hindsight, you might think that remediation is this pretty straightforward situation. Problem arises, you fix it, it's kind of it. But as we just saw, it can get pretty complicated pretty quickly, and it rarely looks like that last graph. Monitoring response is typically set up correctly. If you set up correctly with monitoring tools and you get the alerts to the right person, that's pretty easy. But the remediation is a lot harder to quantify. It has fits and starts, it has many different avenues that can be taken, and it's rarely straightforward. So if you don't have a timeline of events and to quantify what's happening and when, it's incredibly difficult to go back and refine steps for future processes. So, like I said, response is relatively easy, and then we get into the remediation. So this is kind of a graph of what that might have cost. So the 12 minutes it took to actually respond to the issue, to get someone on that phone, cost $50,000. And this is based on that State of DevOps report that's been talked about a few times. So that's a lot, but 600,000 is the number that it took, roughly, to actually remediate and resolve this issue. So imagine what just a 5% improvement in that remediation could mean for your bottom line or even your team's happiness. So unfortunately, I am not here to tell you what that means for your infrastructure, what it means for your department, but I do know that if you don't have those steps easily, visible to you and your team, it's going to be really impossible for you to find that out yourself. That's it. I'm done. That was quick. Lightning talk.